welcome to our channel. In this session, we will discuss the concept of operator precedence parser. Before understanding operator precedence parser, first you need to understand operator grammar. What is meant by an operator grammar? Simply a grammar that works with a simple mathematical operators is called operator grammar. Now, the main restrictions to form a grammar as operator grammar is the first thing, there are no two adjacent non-terminals. That is, in the right side of the production, no new non-terminals are appeared. You got the point? In the right side, two non-terminals are not adjacent. In between non-terminals, compulsory you need one terminal symbol or only a single non-terminal is sufficient. Second one, there is no epsilon on the right side of the production. So remember, if any grammar that satisfies these two conditions, such a grammar is called operator grammar. For example, A tends to some AB. This is an operator grammar. Why? There are no two non-terminals are adjacent, and this is also adjacent. This is also operator. For example, this is also operator. Got it? And for example, S tends to SA. A tends to plus some star. Now observe, is this operator grammar? No. Here S comma A are two non-terminals. The two non-terminals must not be adjacent. So this is not an operator grammar. Now how do you convert? Very simple. S tends to S. This capital A is replaced with plus or capital A is replaced with star. Now it becomes an operator grammar. Now you got the point? This is the concept of operator grammar. Why we discussed this one? Operator precedence parser works on this operator grammar. It works on this operator grammar. And the one more advantage of this operator precedence parser is the grammar is, even though ambiguous, it can do the parsing. That is, the only operator precedence parser works on the ambiguous grammar also. Now, so we understand the basic criteria, that is on which type of grammars my parser is working. Once you understand, then what is the step? How do you perform the parsing technique? Now I will implement the parsing. The procedure is very simple. First step is you need to construct an operator precedence table. What is mean by precedence table? The relationship among the operators. The relationship among the operators, that is called precedence table. Observe, I have two operators or two terminals, whatever it is, A comma B. If the precedence of A is greater than precedence of B, then it is represented with the relation greater than. If the precedence of A is less than precedence of B, represented with the relation less than, and both are equal with the relation equal. These are the relations. Now in the table we are writing the relationship between the two operators. And one more thing is, an identifier has the more precedence than any other terminal or any other operator. Identifier has more precedence. Remember, at the same time, dollar has less precedence than any other symbol. Dollar has less precedence than any other symbol. Now the last point is, if any two operators have equal priority, that is, any two operators have equal precedence, in such a case, we are checking the associativity. We are checking the associativity. Now these are the conditions for constructing an operator precedence table. Once the table is constructed, based on the relation, we are performing the shift reduced parsing. Now I will explain this one by considering one example grammar. Okay. Now on that grammar, we are performing some shift reduced also. Assume my example is E tends to some EAE. E tends to some EAE slash some identifier. A tends to some symbols plus star. My string is, that is my input string is ID plus ID into ID. Now, first to check. Now, question is perform operator precedence parsing on this grammar. First, you need to check whether this grammar is operator grammar or not. No. Why? E, two adjacent non-terminals. So, what is the first step? The first step is you need to convert this grammar into operator. How simple? Capital A is replaced with plus, so capital A is replaced with star. So, E plus E or E star E or ID. Now, this is not at all required. Now, this is my grammar. Clear? Now, construct the precedence table. What are the things we have? Identifier plus star dollar. Similarly, identifier plus star dollar. Now, ID and ID, it is not possible. Why? For example, in my situation, assume one time ID is equal to some 6, another time ID is equal to 7, another time ID is equal to 4. Identifier means the value changes. So, depending upon the value, the relation changes. So, there is no relationship between the identifier. Anyway, identifier has the highest precedence than any other. So, identifier is greater than. That is, these are the symbols that are present. If it is on the stack, it is on the input string. Suppose plus is the less priority than identifier. If plus and plus, so there is no relation, or based on the associativity, you can write greater than also. Similarly, star and star, greater than. Suppose see, plus and star, plus is less than star and plus is greater than dollar. Coming to star, star is less than identifier, star is greater than plus and star equal priority. Based on the associativity, star is greater than star and star is greater than dollar. Now, dollar has the less priority on everything if the same dollar. Now, this is the precedence table. Based on this table, now I am constructing shift reduced parser. Now, before constructing shift reduced parser, first you need to know one basic information. When we are performing shift operation, when we are performing reduce operation. Clear? Suppose if the top of the stack, precedence is greater than input symbol precedence. If the stock precedence is greater than the input, then we are doing reduce operation. If the top of the stack precedence is less than the input string precedence, then we are doing shift operation. Remember these two terms. If it is greater than, reduce. If it is already less than or equal, we are doing shift operation. Clear? Based on these two rules, I am parsing this input string by using shift reduced parser with the help of operator precedence table. Clear? Now, stack the relation input string. What is the action we are doing? Initially, stack is empty. Now, what is my input? ID plus ID into ID dollar. Now, step by step, observe the relation. Here, top of the stack is a dollar. Input to first symbol is ID. Check. Dollar has less priority than ID. If the top of the stack has less priority, then what we are doing? We are doing shift operation. Less than. Dollar is less than ID. We are doing shift operation. Dollar ID here plus ID star ID dollar. Now, top of the stack is ID is greater than plus. ID is greater than plus. If the top of the stack is ID, then what you are doing? Reduce operation. So, ID is reduced to their non-terminal. E tends to ID. Now, dollar E plus ID star ID dollar. Now, here it is a non-terminal. There is direct reduction is not there, and generally the non-terminal has the less priority than this terminal. So less than. If it is less than, simply shift. Simple thing, if it is less than, shift to. If it is greater than, reduce. Now $E plus ID star ID dollar. Again, plus is less than ID. If the plus is less than ID, then shift move. $E plus ID star ID dollar. ID is greater than star. ID is greater than star, then reduce E tends to ID. $E plus E star ID dollar. E tends to E star. Now E has less than star. E has less than star. If it is less than, again shift move. $E plus E star ID dollar. Star and ID. Star has less priority than ID. Star has less priority than ID. Again we are doing shift operation. $E plus E star ID dollar. Now ID has more priority than dollar. If it is more priority, then what you are doing? Reduce. E tends to ID. $E plus E into E. Here dollar. Now dollar is the least priority. Dollar is the least priority. So greater than E into E. Any possible reduction is there? Yes. So what is my operation? Reduce. E tends to E into E. So $E plus this is reduced to E. Again dollar. Again this E is greater than dollar. If it is greater than, again you have the reduction step. E tends to E plus E. Now $E dollar. Now here the top of the stack is the starting symbol and the input buffer ended with the string. That means my entire string is parsed successfully. So the final state is accept. Clear? This is the way how do we parse a string by using operator precedence parser. That is the end of operator precedence parser. Thank you.